So I guess we're good. We're online. Hi everyone. Good to be at ZeroNights, at least to be able to give my presentation. So I hope everything is okay. Like if you're in the chat, like let me know if you can hear me fine. So today we'll talk about memory forensic and cloud memory analysis. So I will explain the difference and see what we're gonna cover. So for those who are in the room, if you want to ask questions later or even now, you can have access to the chat box if you go now on Twitch. So if you go on Twitch now on this address, you should be able to have access to the chat box, and same thing if you're not at the conference, but if you want to participate. I will give the link again during the Q&A section, but just so you have it now. So let me introduce myself. So my name is Matt. I'm the founder of a startup called Come. We are purely focusing on memory analysis. Some of you may already know me because I've been doing some memory forensic work over the past 10 years. So I recently started this company a few years ago to purely focus on that and make it simpler and to democratize it. I'm also the founder of a conference called OPCDE, so it happened in Dubai and in Kenya. And actually we're going to be releasing a short documentary about the Kenya edition that happened last year very soon, so it should be on YouTube next month. I'm also on the review board of some conferences. And according to the shadow brokers, I'm a fun guy. So I posted that slide on Twitter. I don't know if it has, anything to do with me being denied of entry on the territory, because the official excuse was my middle name was missing on my visa. To be honest, I've never heard that being an issue anywhere. So yeah, I was really looking forward to ZeroNights to meet some of the local community. And actually, funny thing, for those who do not speak Russian, it basically means, well, since we didn't get the chance to meet in Vegas, what about we meet in St. Petersburg? So we can have some okroshka. And the second word for the horseradish drink, funny enough, under some circumstances on Google Translate, it translated to something totally different. So I guess that's how legends are starting about Russians hacking Google Translate, But yeah. No, okay. But yeah, so yeah, that's basically what happened yesterday, or I guess 2 days ago. So basically in total, I spent 2 hours in Russia, and then I had to fly back because of my visa. And funny enough, people have been quite supportive on Twitter since we're talking about doing a stream of the presentation. Well, Edward Snowden gave some recommendation for the audio and the video because I watched his interview on the Joe Rogan podcast, and I was like, oh wow, the quality is actually pretty good. So that's my attempt of having a good quality presentation. Started from Okroshka. Well, either you started the stream late because it's live, or you should be able to see it before. But yeah. And also, the good thing is since there is a chat room, so if you have any question, you can just ask in parallel, and I can also reply to it. So this is Bradley from Jira Security, because I was asking him a bunch of questions about some Linux stuff, and he was like, "Oh, I want a paper board with my picture on stage." Well, since I'm not even on stage, I cannot do that. But I said, "Okay, I will put a quote of you on it." For those who are not familiar with his work, he has been doing a lot of really good Linux security stuff over the past 20 years. Okay, so that's it for the introduction. So that's what we're gonna talk about today. So like I was explaining, I'm gonna kind of explain what I mean by the paradigm shift around memory forensic and memory analysis, and then I will cover like the different categories where like memory analysis can be useful. Okay. So some of you are saying you have some issues with the lag. Oh, interesting. Let me check here. Well, I just turned down the arrow. Yeah. So yeah, let me know if you still have some errors. I decreased the quality of the video. Okay. Let me know if you still have some buffering issues. Okay, so regarding memory forensic, so initially it was designed for defense, but if you look concretely, like over the past years, there is not more people using memory forensic compared to 10 years ago, except for a very specific use case where people would use it mainly for offense, and they would leverage like proc dump or like any memory acquisition tool just to be able to run Mimikatz on them. So there's the Stolen Pencil campaign, for instance. And I think even now some of the EDRs are blocking proc dump. And from that, people mainly use it just to recover passwords. It's like, that's basically like the only thing that's interesting people. Either because it's too complicated to do memory forensic now and it does not scale really well, or because attackers would not be shy to use more like sophisticated like techniques. Even though like in that case, almost in 2020, it's not that innovative anymore, but it's becoming more and more common. So the problem for defense is memory forensic is still like very time consuming. People don't have many resources. And memory forensic is mainly used by people who are like used to Python. So there is very low expertise when it comes to like kernel debugging and everything. Whereas like memory analysis involves people who actually know to use the debugger, or who are like very familiar with troubleshooting things on their own. So this is a good question, actually. I cannot try YouTube. It needs 24 hours. But yeah, so for the Stolen Pencil, if you look at the attack itself, I will be posting the video after anyway. So if you still have issues, I can always post like the full video. But yeah, in the MITRE attack map, funny enough, they have a software section. They're putting like Mimikatz and PSExec, but they don't put. But yeah, and but they don't put like proc dump or any other tools. So it kind of shows you that even though people are talking a lot about the MITRE attack, when it comes to like evaluating some attacks or like checking what could have been used, generally it's still giving you like a very rough overview, and even things that should be mentioned, for instance like proc dump, like they're still not mentioned. But yeah, so now we're almost in 2020, and if you look at memory analysis or even memory forensic, nothing has really changed since, I don't know, like 2005, I guess. And it's still like very slow. A lot of the tools that are written in Python are not really like designed to like manage like such big amount of memories, because now, while in 2005, what you would be analyzing would be, like 4 gigabytes, whereas now, like some servers can be like 128 gigabytes and more, and it's becoming increasingly common. Oh well. I mean, I can try to decrease again, but. But yeah, and even now when it comes to memory analysis, so a lot of the images that are being analyzed are still like raw memory images. And if you look at, for instance, Linux, for instance, there is no progress that has been done over the past like 10 plus years, because if you use like only raw dumps, there's a lot of really important information you are using. So if you look on Windows, for instance, on Windows, so if you take like Windows Debugger, for instance, it's using the Microsoft Crash Dump for a reason. And because of that, it had been working pretty well. So it's very surprising there's nothing similar on Linux, for instance. There's Crash, which is attempting to do something similar. So they would use like the core dumps. But when it comes to like actual like memory analysis and memory forensic tools, they're still like behind when it comes to this. So the system memory dumps have a lot of value. So if you look at Crash Dump on Windows, so you have the full ones, but also like the small ones, which is used in some of the campaigns when they dump the memory of LSAS, for instance. And same thing if you look at the core dumps on Linux. So we'll talk about proc core in a later section. But there is a lot of useful information. Actually, even companies like Facebook are like starting to use them, surprisingly enough. Raw dumps are like not really good. Even Dino was mentioning it because he was talking on a thread regarding it. Crash analysis using metadata makes a lot of sense, and that's why if you do not have this extra metadata, because it's already hard enough to analyze all those images, especially now because of all the different versions of the OS, since it's increasing exponentially, it's becoming like really hard to analyze if you don't have a proper like structure. So now Windows, there's few ways to make a dump. So the most obvious one is to use like the task manager on Windows, which is like the most common one. It's present everywhere. Even on Visual Studio, you can create a dump. And even now, like Microsoft just, I think it was like 1 or 2 years ago, So there's proc dump obviously to do a memory dump, but they also have like proc dump for Linux. And if you look at the actual source code on GitHub, you will see that basically there's nothing. They're just using jcore and running that process behind the scene. So wibble wobble. Are you still having some buffering issues now? Interesting. Okay, because like the video bitrate is pretty low now. I can decrease again. Let's see. Okay, I just decreased it again. Let me know if it's still being a problem. So that's for Windows. And now if you look at cloud providers, so like I was saying, like it's becoming an exponential problem because now if you look for Linux, for instance, and I don't know if you already knew that, but Ubuntu, for instance, has multiple flavors, one per cloud provider, and that's becoming a pretty big problem because if you do like the old-fashioned way of like profiling each operating system, so at each update it would break, and if you have to support like multiple cloud providers, like traditional ways would not work at all. And even now, like if you look at cloud providers, they're not really providing much documentation around it. And even if you're using Windows subsystem for Linux, it would also have its own like Ubuntu version and also other like distribution. Like if you do like the uname command, you would see like the Microsoft in parentheses. So like building a symbol database for Linux is becoming a pretty like strong problem now. And but fortunately there's some features that can be leveraged from the cloud providers, and if you are on premise, so if you have your own virtualized environment, so let's say Hyper-V for which has some pretty good undocumented API where you can access the guest memory of the virtual machines. So you just need like, so each virtual machine has a worker process called VM WP. So I first published that tool in 2010. It was working like purely in user mode, and after that I totally left it out. And Gerhard, I don't know if he's at the conference today, but last year he started to look at Hyper-V and Windows Defender Application Guard, which is a feature in Internet Explorer, which is pretty cool because it's virtualizing one of your tab inside Internet Explorer. He started to look at it and just like added the support for like Windows 10 and Windows Server. So the downside is, okay, that's to use a driver now. I really think Microsoft should just like open like the APIs for that, so people can just like do it in a proper way. Because at the end of the day, like if there's no API, people would just like look around it. And when it comes to like virtual machine introspection, that would be like a pretty good thing to have. So like it's still like a research topic for the past 10 years, but I don't think it would be surprising to see like VM introspection like agent that are like working like in a stable manner in 5-10 years, depending if it's becoming a priority for the cloud providers and software vendors. And now that Microsoft is basically a security company, maybe they will do it first in ATP, so that will not be like surprising either. Mathieu Taral also did some really good virtual machine introspection on the topic. There's also Tobias Zillner that published some interesting stuff around it. And like I was saying, there's also like some very interesting features that can be leveraged from cloud providers. So one of them is to just simply be able to run a command on inside a virtual machine without having to like SSH or RDP to the target host. And that's pretty useful, because the way you would do it normally for incident response, would not really like, would still apply for like cloud providers for like your virtual machines, but there is like better ways to be leveraged for that, and they're like very simple to use. For instance, we have a lot of users of Dumpit or like Windows memory acquisition tool that are using either like the Azure run PowerShell script command, or the SSM feature on AWS, where you can just like launch a command directly. For Linux, for instance, you can even like pull a Docker container and run it. So that's very useful, and you can like do that on a lot of VMs very easily. iMemory instances. So now, like I was saying, it's very common to have servers with like 128 gigabytes of memory. And even if you look at, now I'm thinking I should just have recorded the presentation before, and you could have like just played the video, I would have would jump in just for like the Q&A section. But yeah, so on AWS and Azure, but on AWS particularly, you can see they're offering iMemory instances with up to like 24 terabytes of memory. So that's bigger than most of our drives now, and so it's mainly used for like database and SAP machines. But if you think of that as being bigger than like our drive, soon like being able to understand like memory properly and to scan it is going to become more and more important. Intel has this thing called the accelerated memory scanning. So far, like no one has been really using it, but you could see like, oh, it could be useful for something like this. If you have a high memory instance and a GPU, that you would use just to scan like memory. When you have like few terabytes of memory, that will make a lot of sense. Serverless. So I don't know if some of you have ever used like AWS Lambda or Azure Functions, but basically they're just like a quick way to have web applications. You just like have one file of JavaScript code or like Python or like those like scripting languages, and it provides you an API, so you don't have to host like a full like microservice. And then you can also have like real-time deployment. So if you make a modification in GitHub, it's gonna automatically deploy the modifications. And on Azure, there's something called Process Explorer, which is part of the Kudu console to manage your application services. But like I was saying, it's a script running on top of an existing layer, so either like Node or IIS. And there is an API to it. So if you look at it, you can also like have a dump of it. So you can have a dump of the like a web server, either like the IIS instance or not. So here, for instance, from the API, you can see there's like 3 processes running. So there's 2 IIS instance and 1 node instance. And if you keep going forward, what you will see is it gives you an option to get a memory dump for that file. And that's pretty cool, because so far I haven't seen anyone like properly like using that if you want to do like troubleshooting or anything. But at the same time, not many people are really using like Azure functions or like AWS Lambda yet. But for sure, like they're like giving some very useful features for it. Yeah, that's basically the API. So you provide the process ID, and then you get the link to get the process dump, which is basically like a slash dump, right? And then if you open it in Windows Debugger, well, you can see some interesting things, because you can actually know what's being run on the Azure or Azure Stack, because some people also have, some companies, you know, have their own private data center with Azure Stack. And you can see if they're actually updating their host, and you can get the exact version of those hosts and even DLLs that they're using. So for instance, like the JZip DLL. So that's one. And here you can see they're using so Windows 10, but 14.993. And if you look, it's basically like out of support in that case. So that, you know, that's a pretty recent screenshot actually. I took that screenshot like a week ago or 2 weeks ago, and then Azure function. So it was actually running on an out of date Windows, and if you look, it had been out of date since April, which is a bit surprising from Microsoft, you know, because the whole premise is like, okay, use like cloud, and you know, especially for this, you know, where you don't have to manage the stack below, you would expect it would be like up to date. So for Linux now, Linux is everywhere when you look at any cloud provider. So even if you look at Microsoft Azure now, it's the most popular like operating system. And that article is from last year, but there is also another one which is more recent that was saying that Linux is basically more common than Windows for Azure. I'm sure like Kubernetes and containers have a lot to do with that, because that's a very common use case for Linux. But everything is Linux if you look at the cloud, but there is no like proper like memory analysis or even classical incident response tool for it. So that post from the Linux newsletter, so you can see one of the engineer was saying that there is more Linux VM on the actual like Azure stack. So we should probably see like more like advisory from Microsoft, and even that MSRC is receiving some of the like bug submissions for Linux and accepting them. So it's definitely like a different time. But even if you look now, not only memory analysis but incident response in general, the tooling on Linux is very weak. And that's a pretty big problem. A lot of the tools or scripts, you know, like either in Python or PowerShell, they are very superficial. People rely a lot on logs and all those things. So when it comes to doing actual like in-depth DFIR, there's not much. And if you look at Kubernetes and Dockers, where like your containers are being created and destroyed, etc., etc., it's a big gray area. So there's not much around it. So unless you're expecting to see like SQL injection or like command injection, things like that, so you would see it in the logs and stuff. But otherwise, you not see it at all. And I would not be surprised to know that there is a lot of like Linux exploits in the wild that are being used now, because if you'd have to investigate, that would be actually very complicated. And even if you look at security mitigations across like all cloud providers and all vendors, they're not that uniform. Even like KSLR is not enabled in some of the cloud providers if you create like a default image. So that's, I would say that's pretty bad, considering that the whole premise is that they would manage it for you, so you'd expect them to have a lot of the security like features enabled by default. I assume like the main reason is because they are scared to break compatibility, but at the same time, things like KSLR have been around for a while, so we'd be surprised if things like this would break compatibility. And if you want to do like a memory acquisition, it's very difficult. I tried like I'd say at the beginning of the year, it was almost impossible because most of tools didn't work, and if they do, they just give you like a raw memory image. Even like recently, Microsoft published a tool written in what was I forgot the language name. It will come back. In Rust. They wrote a memory acquisition tool for Linux in Rust. That was cool, but like it's creating like a raw memory image. So at the end of the day, you get a raw memory image, but you cannot do anything on it, just like a grep, which is a bit a bit sad if you're like in 2020. Especially if you have to analyze like servers, you won't get with like gigabytes or like or a terabyte of memory. You won't go far with a grep. And proc core on Linux is becoming more and more interesting. So Crash is getting like more traction now. It's not very user friendly, but it's a good start in terms of like architecture. Now you can use like dump it also. So there's a free container available on Docker Hub where you can just like use like that container on your VM. So as long as you have Docker installed, you can just run that command below, and that's it. It will acquire like the memory image, and you can even send it to one of your storage accounts. So either if it's with Google Cloud, AWS, or Azure, you can just do that, and that's pretty neat because it's very quick. It can just like take like few seconds, and even if you have to send it to another like cloud providers because you're using their internet connection, or to a local like storage account, it's gonna be like copied almost immediately. And on Linux, proc core is interesting. So even Facebook, like I was saying at the beginning, is looking at it, and for that, like I'm still curious to know like why they use it. I didn't know that Facebook had a kernel team. I still have this image that they're just a PHP company, although they're doing much more stuff now. But they're like acknowledging that there is a problem for like debugging tools on Linux, and that's why they're trying to improve the VM core info structure, which is present in proc core. Containers. So there is some interesting features to be leveraged with containers. So if you look at Kubernetes, they have this thing called the container lifecycle hooks. So you can have hooks after starting and before stopping. So here, imagine if you could take like a memory image or just like the metadata and diff it, when they're starting and finishing to see if anything has been changed on the system. That could be like a very useful feature because you would have your base image when it starts, and then you would compare it with when it stops. Then you could actually like do memory diffing on some specific part or a specific like kernel memory structures. Those are some of the references, so they will be in the slides and some of the links that I was mentioning in the presentation. But yeah, as a conclusion, funny enough, like analysis didn't really evolve that much since 2005, and I feel like we're hitting a bit of a glass ceiling for the past like 10 years at least. There's not much that really happened around memory analysis. And if you look at Linux in general, it's becoming quite critical because even EDRs are just starting to support like Linux, and they're like very basic compared to their Windows equivalents, and a lot of the tooling on Linux is still very weak. So given the fact that Linux is basically like the most important OS when it comes to like critical well, not critical infrastructure per se, but like all the cloud virtual machines, since most of people are using like Linux, it's still very surprising that there is no proper like response or investigation tools for Linux. So if you're still around, you can ask your questions now. And not sure if there's still anyone in the chat, since it was buffering and having some issues. But yeah, that's pretty much it. Let me check something. Okay, thank you.